Hello everyone, I hope you are all doing well. In this video, we are going to study about the routing information protocol. We will be going to study about the basics of this routing protocol. Plus, we are going to perform a practical in packet tracer, and we will see that how can we set up a routing information protocol in packet tracer, and we will also test its performance in the packet tracer software. So before moving to the practical, we have to understand that what is RIP and why do we need this in the networking. So basically this is a protocol designed for the routers, that how can they communicate with each other, and how the data will be transferred from one router to the next router. So this protocol basically works as the metric for hop count. So this is based on the metric of the number of nodes connected to the specific router, and this router information protocol will tell us that how many hops we have to travel to reach to our destination. So each hop will have its own information, and it will carry its own data. So from source to destination, there will be a number of devices, intermediary devices, from which our data will be going to travel, and it will be eventually reached to its destination. So basically this protocol will enable the routers to save the information of the routing table, and then all the routers connected to each other will simultaneously change its routing table and their information. So that's the basic information of routing protocol. So now we are going to move to its practical. So for this practical, I'm going to use two routers, and there will be two switches, and there will be two PCs as well. So first of all, we have to use the routers. I have to put them in our working scenario. Then we are needing two switches, and lastly we need two personal computers. So we have put them in the working space. Now we need to connect these devices. So I'm connecting these devices with automatic wire, and this wire will automatically decide the um, type of the wire needed to connect these devices. So now we need to connect this router 0 to this router 1. So for connecting the router 0 to router 1, we will be needing the serial DCE cable. So for serial cable we need a port. So this multi-protocol port will be established for this link. So first of all we need to turn the router off, and then we need to put the port and turn the router on. Similarly, we have to perform the same step for router 1 as well, and now we have to turn it on. So ports have been set, and now we need to connect these two routers using the serial port. So now we can see that all the links between these devices have been set up, and now we need to provide the network addresses to these devices. So for better understanding, I'm writing down the addresses. uh, I'm giving the network address to this 50 dot 40 dot 30 dot 0, and this link will be 10.0.0.0, and this link will be 72.168.1.0. And for assigning IP addresses to PCs, I'm assigning it as 50.40.30.2, and its default gateway will be for 50.40.30.1. So you need to remove this DNS server here, close this down, and now we need to assign the IP address to PC1, and its address will be 172.168.1.2, and I'm just copying this, paste it here, and its default gateway will be 1.1, and remove this DNS server. So now we have to assign the IP addresses to these ports, from router to switch and from router to router. So we can assign these by using the commands, and we can also assign the IP addresses using this interface. So from router 0, for interface gigabit ethernet 0/0/0, I can assign its address as 50.40.30.1 and turn this router on, turn this port on. Similarly, we need to go to the serial port here, and we need to assign the IP address as 10.0.0.1 and turn this port on. You can see that we have an option here for clock rate. Clock rate means that after how much time your router will be sending the information to the next router, or you can say that after how much time it will refresh its information or refresh its routing table. So we have limits, time limits here, 72,000. These are the milliseconds here, and now we need to close this and go to the router 1 and assign the ports and fix the ports here. So we need to go to gigabit ethernet 0, 172.168.1.1, and we need to turn this port on. And here we need to assign this port an address 10.0.0.2 and turn this port on. So we can see that all the red ports are now turned to green. It means that we have successfully arranged, or we have successfully provided the IP addresses to these devices, and now we can move to the next step. So right now we can see that although all the ports are green, but if we send a message from PC0 to PC1, we can see that it will not be delivered, and you can see that it is failed. So for better communication or for successful communication, we need to configure these two routers. So previously we have configured them using this static protocol here. You can see that we have provided the one network, and its mask and we have to provide the next hop or next node. But in this scenario we are going to use RIP protocol. You can see it's under the static option, so just go to the RIP and we need to provide here the addresses of the two networks. So network address of this router, there are two networks connected to this router 0. One is 50.0.0.0 and second one is 10.0.0.0. So we will be providing router 0 these both network addresses to 50.0.0.0. Just click on add. Now provide 10.0.0.0 and click on add. So now we need to go to router 1 and provide the network addresses. Go to RIP option, 172.168.1.0. This is class C, so it will be 0.0. This is class B, sorry. So click on add. Now we need to provide another network connected to it, 10.0.0.0, and click on add. So we have successfully provided the network addresses to both the routers. So let's send next message and let's see if we can send a message from one PC to another PC using this protocol now. So I'm sending a message from PC 0 to PC to router 1 and you can see that this is successful. Now we need to send the message from PC 0 to router 1, so it is also successful. Now we need to send message from PC 0 to PC 1. Okay, so in first message this will be showing us as failed communication because first packet is used for the routing table. It will be consumed for the updation of the routing table, and when we send the next message it will be successfully sent. You can see that the message is now sent successfully. So this is the RIP protocol and you can see that we have successfully configured the network using two routers, and there are three different networks here involved here, and we can communicate between these three networks. So I hope you have understand this concept and let me know if you have any question in this topic.